All right, so in this problem here, we'll do rules. As usual, now we'll read. In Mr. Coring's mathematics class, students were given rectangular greeting cards. The table below shows the length and area of each card. So we have card A, B, and C, side length X, 5 inches, 10 inches, 15 inches, area Y, 15 inches squared, 30 inches squared, 45 inches squared. Which equation represents the relationship between the area of a card Y and a side length of X? So we've read the question, we read the options. Oh, we have option A, Y is equal to X plus 17. B, Y is equal to X divided by 3. C, Y is equal to 3X. And D, Y is equal to 3X plus 11. All right. Now remember, whenever you see the constant directly by the variable, this is telling us that we're going to multiply. Okay. So this means that we're going to multiply. All right. So whenever you multiply, Y is equal to 3 multiplied by X. So let's see if that's right. So now, well, before we do that, let's underline the question. So the question here, all right. So which equation represents the relationship between the area of a card Y and a side length of X? All right. So we underline the question. Now we're going to label and annotate. Okay. So we have Y values here, the X values here, which is the side length. All right. So rectangular table below that shows the length and area of each card. The length and area of each card represents the relationship between the area of card A, of a card Y, and a side length. And a side length of X. All right. So we already know that the area, all right, so we're going to do a little bit of labeling now after we box some key terms and key words. So whenever you see the word area, this means that we're going to multiply. All right, we're going to multiply. So we know that the side length 5, when the side length is 5, Y is equal to 15. Okay, so what we're noticing here is that as X increments by plus 5, Y is incrementing by plus 15. Okay, so here we have plus 5, plus 5, plus 15, plus 15. Okay, so we can do 15 divided by 3. Okay, to figure out what our constant is. So we'll do 15. This is what makes math so beautiful. 15 divided by 3 is equal to 5. Oh, sorry about that. So 15 divided by 3 is equal to 5, okay? So we know that 15 divided by 3 is equal to 5. Oh, I'm sorry. 15, which is the change in Y, divided by 5, the change in X, equals 3. We divided the change in Y, which is 15, by the change in X, which is 5. 15 divided by 5, ladies and gentlemen, is 3. So now, if we multiply, and this is what she had here, looks like she erased it, but she was absolutely correct. If you multiply it by 3, times 3, times 3, times 3, 5 times 3 is 15, 10 times 3 is 30, 15 times 3 is 45. So Y is equal to 3x. So 3 multiplied by whatever the x value is, if it's 10, that would equal to 30. Okay? So the answer to this problem, ladies and gentlemen, is C. So we just evaluated here. Cross this out. We evaluated here. We multiply 3 by 10, we got 30. 3 by 15 would be 45. Y is equal to 3x. All right. So in this case, the concept is okay. So in this case, so we have, this is accurate. It's accurate. Concept, okay. Process, I don't know if she had anything boxed or anything underlined, so this is going to be a process that's weak. All right. Okay, so I hope this helps y'all out to solve problems like these. Remember, we're looking for the pattern here. The x increases by 5, the y increases by 15. We did 15 divided by 5, we got 3. So if you multiply the x values by 3, you'll get the y values. 3 times 5 is 15. 3 times 10 is 30. 3 times 15 is 45. So that tells us the equation to figure out whatever y is, we have to multiply x by 3 in order to figure out what y is equal to. All right? I hope that helps. You will see problems like this on the Common Assessment. All right, thank you.